So today we will do another little subtopic in percentages, and this is going to lay the groundwork for our understanding of a particular application of percentages, which we will do later. And that is the idea of profit and loss. So all we're going to be doing here, or all I'm going to be doing here, is just giving you another tool to approach real life applications, which we'll be doing later. And I know I've talked about it a lot, but I promise all of these things I'm giving you now in this part of the course is just laying the foundations for the applications. The applications are the heart and soul of where these mathematical techniques shine. So, all we're doing here is we are looking at expressing quantities as percentages. So we'll be given two numbers and we want to show one as a percentage of the other. So let's look at this first example. And we want to look at what percentage is 20 of 80. Oh, that's actually a shocking 8. Let me redo that. Okay, so we want to show these two numbers as a percentage. And now the order we choose is important because we want to show this as some portion of this. Now, what is a tool we've used to do this? Well, fractions should be the first one that jumps to mind. Percentages too, but percentages are just a type of fraction, a special type of fraction. So we can say, well, what is 20 over 80? So 20 as a fraction of 80. So here we can say, all right, well, we have 20 as a fraction of 80 because it's a fraction of this bigger number, and that with the order we're given is in the question. Now we just want to show that as a percentage. Now what do we need? We need this denominator to be 100 here. So I'm first of all just going to get this fraction in the simplest form. Now 20 goes into 80 four times. So I can say, well, writing this as an equivalent fraction, I can divide numerator and denominator by 20. And that will give me 1/4. So how do I get this into a percentage? Well, I just need to get this denominator to 100. And I've started you off with an easier one because this is a nice round number that we can get to 100. And we can do this by multiplying the denominator by 25. Four lots of 25 give us 100. So we'll also have to multiply the numerator by 25. So let me actually write 1/4 as a percentage. Well, I'm going to write my quarter, and my denominator I'll multiply by 25 to get me to 100, and this one by 25 as well. And I get, sorry, I'm meaning to change the color. It's not working. That gives me 25 over 100. And now I have something in percentage form. We have a fraction, well, some fraction with a denominator of 100, which allows us to straight away just convert into a percentage. So taking one quantity as a percentage of another just requires us to Well, by definition, to put this as some type of fraction, what is 20 as a fraction of 80? And then once we have this as a fraction in its simplest form or not, we can then just convert it to a percentage by getting the denominator to 100. Now, obviously, you can do this with your calculator in a quicker way. I've gone through this in previous videos, but I'm just doing it a bit of a longer way to hopefully give you the intuition there. So, for example 2, let's look at a quantity, but let's look at measurements, because we can express anything as a percentage. Any quantity of another quantity we can represent as a percentage or as a fraction. We can do this with money, with mass. We can do this with measurement, length, and anything. Any two quantities can be represented as fractions or percentages. So let's do, for this last example, let's find 30 centimeters as a percentage of 3 meters. Now I'm going to make a little mistake in my working out here. And this is a common one that students do. And I want you guys to pause the video once I do it and think where I may have gone wrong and ask yourself why. Because that's going to be good for your own understanding, and to be able to explain it to yourself just means you're getting on top of the concepts. And then obviously I'll bring it back and we'll discuss. But I'm going to make a mistake in my working out here. Well, I have 30 here and I have 3 here. So, well, in the last question, all I did was write the first number, the first quantity, as a fraction of the other one. So I'm going to write, well, all right, this is 30 as a fraction of 3. So 3 is a common, should I say, a common factor in both of these. So I can divide numerator and denominator by 3. And okay, well, that gives me 10 over 1, or just 10. Now, I want to get this as a percentage, and we looked at, to change, we especially saw this with decimals, we can do it with whole numbers as well, that to change anything into a percentage, we need a denominator of 100, but we also can't change the value of the number, so we want something to the effect of multiplying by 1. So that's like saying 10 multiplied by 100 over 100, because this process will give me a denominator of 100 to be able to read this off as a percentage. And by having 100 over 100, that's just the effect of multiplying by 1, because we can't actually change this number here. By having any number other than 100 on the numerator, that will be changing the value of this number, which we don't want to do. We want to maintain the number, just express it in a different way. And all right, this is going to give me 1,000 over 100. And cool, well, I have something with a denominator of 100, so that gives me 1,000%. Now, what did I do wrong here? Feel free to pause the video. But I'm going to look at this answer and just look at my question, because there is a logical mistake, a logical fallacy here, because there is no way a unit that is smaller, so centimeters are smaller than meters, there is no way that 30 centimeters is going to be a fraction, when putting that as a fraction of 3 meters, that's going to be 1,000%. That just doesn't work. If you literally, you can measure, you can hold out your 30 centimeter ruler and then measure a line that's 3 meters. In no universe is 30 centimeters as a percentage of 3 meters going to be 1,000. We would expect this to be something smaller than 100%, wouldn't we? Because this is a fraction of a bigger quantity. Now, if you picked up on what I did wrong, that's fantastic. But if you haven't, I'm going to show you now. Well, I need my units to be the same. Because we're dealing with fractions and percentages, well, we need these two quantities to effectively be speaking the same language. So we want the exact same unit here. Because converting, for example, this one to centimeters will give me something bigger than this. So my calculation will work because this will be a fraction of this. So, and this is a common mistake that students make, the one that I've done here. I've seen that happen. So when you get your answers, and this is a good lesson just as you're moving through school and working on these types of questions, always do a little sense check when you've gotten your answer. Does this make sense and why or why not? And this exact process that I've just run you through is kind of what you want to get into the habit of doing as you complete particular questions. So I know I've done something wrong. So let's try to rectify that. So we want to find, well, 30 centimeters as a percentage of 3 meters. Now, to get that in the same unit, we know that there's 100 centimeters in a meter. So 3 meters is essentially identical to 300 centimeters. Now, when we put this as a fraction of that, we're going to get some portion. We're going to get some percentage smaller than 100 because 30 centimeters we know is not bigger than 300 centimeters. So let's begin with our working. So I'm going to write this as 30 over 300. And that now, I have a numerator that is smaller than our denominator. I have a proper fraction. And now I just want to get this denominator to 100. And some of you may have picked up on the fact that this 300 can be brought to 100 just by dividing by 3. And we'll do that to the numerator as well. And we're going to end up with 10 over 100. And now we have a denominator of 100. So we can express this as a percentage. And this will be 10%. Now that seems like it kind of passes the logic test, right? This is a far more kind of, this answer makes more sense. This answer of 10% makes more sense because if you were to make 300, if you were to make 300 centimeters out of a bunch of 30 centimeter rulers, well, you can just line up 10 lots of these rulers and that'll give you 300 centimeters or 3 meters. And one of your rulers, your original one you started off with, would just make up 1/10 of your entire distance. Or in other words, 1/10 can be written as 10 over 100, which is an equivalent fraction, which can also be written as 10%. This now passes the sense check. And I'm going to keep referring to this notion of a sense check as we move through every subject, a variety of different subjects, because I know I've waffled a little bit on about this type of thing, but it is a powerful tool when working through mathematical problems. It is an exercise in logic. And that is essentially what maths is. Maths is based on logic and kind of numerical, making sure things are numerically make sense. So I know I went off the rails a little bit at the end there, but this is just to sum up the importance of units and just looking at when we express quantities as percentages, we are taking one of these as a fraction of the other, which we can then find it, we can find this one as the percentage of the other one. And every time we do this, especially when you encounter units, so you can have, milliliters, liters, you can have days, you can have seconds to minutes, you can have grams to kilograms. We need to make sure we have the same units here, which we got here. So some of these may require a unit conversion, but that is, in essence, expressing quantities as percentages. And this will lay the groundwork for when we work on profit and loss in a few videos' time. I'll see you guys next time.